Hi friends, today we will see the production of rotating magnetic field in induction motor. Okay, so when you give three-phase supply to the stator of an induction motor, so there will be a production of three-phase flux. Okay, so that resultant flux, the resultant of these three-phase flux will rotate in the air gap. Okay, so now we'll see how that will rotate. Okay, so if you give three-phase supply, so three-phase flux will be produced. So now I will draw the three-phase flux waveform. Okay, so how to draw the three-phase waveform? Okay, so all of you see how to draw the three-phase waveform. First of all, you draw one waveform, and next make this 0 to 180 degrees part into three parts by making two dots, and from here to here as again make three parts by putting two dots. And so here you just put a mark, that is the maximum value. So here also the maximum value, keep a mark here. Okay, so the second dot and here the second dot you just add like this and extend. It will come like this, and the first dot and first dot you have to add from the downside, and you have to extend. So it will be like this. Okay, so when cross came here, there should be peak on the other side. When cross came here, there should be peak on the other side. When cross came here, there should be peak on the other side. So the waveform is like this. So it is 0 degrees, here it is 60 degrees, here 120 degrees, 180 degrees, and so on. Okay, so this is a three-phase flux that is produced when you give three-phase supply to the stator winding. So this is a phi and this is omega t. Okay, so the maximum value of the flux is phi m. Okay, so let it be phi 1. There are three waveforms, so let it be phi 2 and let it be phi 3. Okay, so you can write phi 1 is equal to phi m sine omega t, and phi 2 is equal to phi m sine omega t minus 120. It's a three-phase waveform, right? So phi 3 is equal to phi m sine omega t minus 240. So because phi 2 starts at 120 degrees, so it is lagging by 120, and phi 3 starts at 240 degrees, so it is lagging phi 1 by 240 degrees. So these are the representation of three-phase waveform. So phi m is the maximum value of the flux. Okay, so now you can represent this three-phase waveform by using a vectors. So let us assume the phi 1 vector will be like this. So phi 2 will be 120 degrees apart, so it will be like this, 120 degrees between them, so it is phi 2, and phi 3 is another 120 degrees, this is phi 3. Okay, so there will be 120 degrees between these vectors. So you can represent this same waveform by using vectors like this. Okay, now you consider these positions. So let it be the position 1, let it be position 2, 3, and this is 4, 5, 6, and so on. Okay, so now at position 1, okay, at position 1, so omega t is equal to 0 degrees. Okay, omega t is equal to 0 degrees. So at this position, what are the values of phi 1 and phi 2 and phi 3? So at position 1, phi 1 is 0, phi 2 is this one, so phi 2 value is here. So if you substitute 0 here, phi 2, so it will be phi m sine minus 120, so that you calculate, it will be minus root 3 by 2 phi m. Okay, so if it is this will be minus phi m, the maximum peak value, and this will be minus root 3 by 2 phi m. Okay, so similarly phi 3, so it will be here. So this point is same on both positive and negative sides, so it will be root 3 by 2 phi m. Understand? So if you substitute omega t equal to 0 in these equations, you will get the same values, right? So 0, this is minus root 3 by 2, and this is plus root 3 by 2. Now these are the values. So now by using these values you have to find the resultant vector. So phi 1 is 0, that means the vector phi 1 will be 0. Okay, so this is phi 1, there is no vector. Okay, phi 2 minus root 3 by 2, so it is a minus value. So the phi 2 positive direction is like this and negative direction will be in the opposite direction, so it will be like this, and magnitude is root 3 by 2 phi m. Okay, so it is because of the phi 2, so the vector is in the opposite direction, and phi 3 there will be positive, no? Positive direction plus root 3 by 2, so it is in the same direction, so it will be like this, root 3 by 2 phi m. Okay, so phi 1 is 0, phi 2 is coming like this, phi 3 is like this, so the angle between these two is how much? 60 degrees. Okay, so it is 120. If you draw like this, it will be 60. Okay, so the resultant will be like this. Okay, the resultant will be like this, so let it be phi r. So phi r is equal to, so you have to find the magnitude of this phi r by using parallelogram law. So by using parallelogram law, if the two vectors are equal in magnitude, so 2a cos alpha by 2. So this is the formula. When both the vectors have same magnitude, the resultant, so 2 into a is this one magnitude, how much magnitude each vector is having, and cos alpha is the angle between the two vectors, 60 by 2. So 2 into root 3 by 2 phi m, so cos 30, that is root 3 by 2 again, so it will be 3 by 2 phi m. Okay, it will be 3 by 2 phi m, 1.5 times maximum flux value. Okay, so if you observe here, the direction is important, the direction is downward direction. Okay, now let us see at position number 2. Okay, let us see at position number 2. So at position 2, so omega t is equal to 60 degrees. Okay, omega 2 is equal to 60 degrees. So when omega t is equal to 60 degrees, so what is the value of phi 1, phi 2 and phi 3? So phi 1 value at this position, phi 1 is here. Okay, so that will be root 3 by 2 phi m, and phi 2 is equal to, so phi 2, this is phi 2 is minus root 3 by 2 phi m, and phi 3, so phi 3 is 0. Okay, so if you substitute this 60 degrees in these three equations, you will get the same values. Understand? So these are the values. Now by using these values, by using the reference vector, so you have to draw the resultant. So phi 1 is plus 1, so it is in this direction, and the magnitude is root 3 by 2 phi m, and phi 2 is negative, so it will be in this direction, and the angle is 60 degrees. Okay, so it is root 3 by 2 phi m again, so the resultant will be like this. This is the resultant phi r, and the same value, so resultant is equal to again 3 by 2 phi m. Okay, so similarly if you do at position number 3, the resultant will be like this. Okay, and if you do at position number 4, so it will be like this. Okay, this will be the resultant when at position number 3, and this will be the resultant position number 4. Okay, that means if you I will draw here. Okay, I will draw the resultant vectors here. So for the first one, it is downward direction, so it is downward direction. For the position number 2, position number 3, position number 4, so let it be like this. So this is downward, and next the resultant is like this, next the resultant is like this, next the resultant is like this. Okay, so if you observe here, so if the wave is progressing like this, so the resultant vector is rotating like this. resulting it is rotating like this. Understand? So as the wave is progressing like this, the resultant vector is rotating like this. So the resultant vector rotates at a speed of synchronous speed. So synchronous speed ns is equal to 120 f by p. P is the number of poles and f is the frequency of the supply. Okay. So when you give three-phase supply to the stator winding, there will be a production of rotating magnetic field. Okay, that will rotate at a synchronous speed, that is 120 into f by p. Okay, thank you.